Welcome back. We are talking about wastewater treatment. Under this option, we are talking about preliminary treatment. In this video, we will discuss about design of gravity chamber, grid channel. So this purpose is to remove the coarse solids of greater than 0.2 mm size, and the separation principle is sedimentation or settling by gravity. And what you see is in this picture, they are a long rectangular channels, and width is smaller and depth is slightly higher. So that H by B, we normally keep it as 1 to 1.5. And the settling velocity of the particles is calculated using the formula. This is Huygens modified equation. Ps is equal to 60.6 into Ss minus 1 into D into 3T plus 7T by 100. Here Ss is specific gravity of the particles. Organic solids, it is around 1.2, and inorganic solids between 2.5 to 2.7. And T is the temperature of the wastewater, and D is the diameter of the particles. The detention period, what we are keeping in this grid channel, is around 45 to 90 seconds. Usually, we adopt 60 seconds or 1 minute detention. The depth of the liquid is around 1 to 1.5 meters. And the pre-board, what we are keeping is 15 to 30 centimeters. So now what you are seeing is the inlet water is entering here, and then this is the water depth, and what you see is this: the bottom is a slope towards one end, so that all the grit particles will be settled down to the bottom. So you can see in the section here, cross section, all the grit particles will be collected at the bottom, and this inlet and outlet is exactly opposite to that, and this is the outlet here. And usually we go for two parallel operations. Parallel operations, say chamber 1 and chamber 2. Inlet is coming through these tanks. And now we'll see in this picture what we are talking this is the sludge cleaning. So how the sludge is removed, it can be manual cleaning or mechanical cleaning. It can be with air supply or without air supply. These channels are operated, usually parallel units. The critical bottom score velocity is nothing but it is a flow velocity such that it should be sufficient to reintroduce the settled particles back into the flow stream. So that means VD, we are calculating using modified Shields formula, 3 to 4.5 SS minus 1 GD whole to the power of 0.5. The terminology is same. Here we are keeping all in CCS units. For D is equal to 0.2 mm, and then we keep a standard value of 4. The VD value is around 0.17 to 0.256 meters per second. So that's why approximately the practical values we take as 0.15 to 0.3 meters per second. And under critical conditions, the horizontal velocity is taken as equal to critical bottom score velocity. And we'll adopt this value as the range of horizontal velocity. Now we have the aerated chamber. And what we are seeing now is only plain gravity settling. Here the wastewater is entered into this channel in a tangential or radial direction, so that it will make the number of cyclic patterns or helical patterns. The particles will move in the helical patterns, and because the air is now supplied from the bottom. So here what you see in this picture, it is a pretty long channel with small dimensions of width and height. So usually the dimensions are, you can see length is 7.5 to 20 meters. Width will be 2.5 to 7 meters. And H is around 2 to 5 meters. B, the width is slightly larger than the height, so that B by H is equal to 1 to 5. The detention time is designed such that it is around 2 to 5 minutes. And the amount of air supply through the air diffuser at the bottom which will be around 0.15 to 0.45 meter cube per minute per meter length. So the settling of this particle is supported when you're sending air. So the particles will be quickly separated and then coming out from the outer outlet weir. This is the outlet weir. Through the outlet weir, all the particles are separated and water is also separated. So now we'll look at a small problem. Design a grid channel. Design a grid channel to remove inorganic particles of 0.2 mm size from a 10 mld sewage treatment plant. Assume T is equal to 25 centigrade and SS is equal to 2.65. So first of all, discharge is given 10 mld, which is equal to 10,000 meter cube per day, which is also equal to 0.116 meter cube per second. So we will use whichever is the value required for conversions. So using modified Shields formula, here the modified Huygens formula, Vs is equal to 60.6 into 2.65 minus 1 into d 0.02 centimeters. Here in this formula, we have to put the diameter of the particle in terms of centimeters. And then temperature is given. So 3 into 25 plus 70 by 100, we are getting a 2.9 centimeter per second. So we are having a range of detention time, like 45 to 90. So we keep it as 60 seconds. So the formula what we have is Vs is nothing but h by t. Settling velocity is nothing but h by t, because this is the chamber. So this is your h and this is your settling velocity, so Vs. So the time taken to fall down in a time of t is nothing but your settling velocity. So Vs is equal to h by t. So therefore h is equal to Vs by t, Vs into t. So using that information, 2.9 centimeter per second into 60 seconds, this will give you in centimeter. That I'm converting into meters. So it is going to be 1.75 meters. So slightly greater than 1.5 meter. So I'm keeping the h value as 1.5 now, rewriting calculations. T is equal to h by Vs. Using that information, the value of what you are getting is around 52 seconds, which is between the 45 to 90. So this check is satisfied. Volume required is equal to Q by T. So we have already seen a number of times Q is equal to discharge is equal to volume by time, because unit of discharge is meter cube per second. So meter cube is volume, second is the time. So volume is nothing but discharge multiplied by time. So that is what we are doing. So 0.116 meter cube per second into 52 seconds will give you 6 meter cube. So h by b, if you assume 1.5, b is equal to h by 1.5. H we already assumed 1.5. Divide by 1.5. We'll get b is equal to 1 meter. So length is equal to L by H is equal to VH by Vs. So that is based on sedimentation analysis. Or here, this is nothing but TH, time of horizontal travel, is equal to time of vertical travel. This is based on the formula. We have the formula. Our time of horizontal travel must be equal to time of vertical travel. Time of horizontal travel means your L by VH. Time of vertical travel means H by Vs. Using this information, we obtain HL is equal to VH by Vs into H. So therefore, L is equal to 11.74 meters. So therefore, freeboard is equal to this much. Where did you get this Vs value is equal to 0.227? That is the important thing. So for this, we are going with the modified Shields formula. So we are having 3 to 4.5 SS minus 1 GD whole to the power of half. So diameter is equal to 0.2 mm. So 0.2 into 10 to the power of minus 3, converting into meters. And G is 9.81 meter per second square. So 2.65 minus 1, and between 3 to 4.5 I'm assuming 4, so I'm getting 0.227. So under critical condition Vd is equal to Vh, so I'm assuming the Vh is equal to 0.227. That value I'm substituting here to calculate the 11.74 meter as the length. So if we adopt a freeboard of 0.3 meters, total depth will be equal to 1.8, 1.5 plus a 0.3, that is 1.8, plus we'll allow some small depth for storage on the grid. And another problem, if you look at a grid channel of 10-meter length, so dimensions are given here. L is given as 10 meters, and H is given as 1 meter. He is handling 10 mld of wastewater. Determine the size of the particles removed from the plant if a horizontal velocity of 0.3 meter per second is adopted. So VH is given here 0.3 meter per second. So we don't know about Vs. First of all, Vs you have to find out, and then D also you have to find out. So D is based on Vs. So these four values are connected using the earlier discussion. Time of horizontal travel must be equal to time of vertical travel, H by Vs. Okay, so this is the condition now. This is one condition we have. So now other condition what we are having is VH is equal to 0.3 meters per second. So L by T, VH is nothing but L by T. So T is equal to L by VH. So what we are having is L by VH. L is 10 meters. VH is given as 0.3 meters per second. So then we are getting 34 seconds detention time. Vs is equal to H by T. This is another way we can calculate. H by T is H is 1 meter and 34 seconds is given. So equal to so much of meter per second, so much of centimeter per second. Using your Huygens modified equation, Vs is equal to 60.6 SS minus 1 D 3T plus 70 by 100. You calculate a D value, which is equal to 0.2 mm size. Volume of the channel V is equal to Q multiplied by T is equal to 0.116 into 34, which is equal to 3.94 meter cube. So volume is equal to LBH, so that B is equal to V by LH. So therefore, volume is 3.94, L is 10 meters, H is 1 meter, B is equal to 4 meters. So you add 0.3 meters to the depth of the channel. So therefore, what you are going to have is you are going to have a long channel. So this is your L and this is your H. And this is the side, this is the B. And so here we are providing some small slope for settling of the sludge. So this is the shaping of the grid channel, right? Now we'll see the calculation for irritated grid channel. So for 30 MLD, we have to peak flow is we are designing, and some suitable data we can issue. 30 MLD is equal to 30,000 meter cube per day, because 1 MLD is equal to 10 to the power of 6 liters per day, and 1 meter cube is equal to 10 to the power of 3 liters, which is equals to 30,000 meter cube per day. And detention time, we are having 2 to 5 minutes in the peak flow So I'm assuming here 5 minutes and calculating V is equal to Q multiplied by T, which is comes out to be 105. So for parallel operation, let us keep two numbers. So area volume of each tank is 105 divided by 2, which is equal to 53 meter cube. And B by H here is 1 to 1 to 5. I'm taking as 1.25. And we assume that this is a small tank. So H is equal to 2 meters, we'll keep minimum depth. So B is equal to 1.25 into 2, which is around 2.5 meters. So minimum depth of H and B we are adopting. So that L will be equal to volume divided by B into H, which is equal to 10 to the power of say 10.6 meters. And air supply will be around 0.5 to 0.45 meter cube per minute per meter length. So length is 10.6. 0.3 into 10.6 is equal to 3.18 meter cube per minute. And sometimes we will also use this sometimes we'll also use a detritus tank. Detritus tank is nothing but this is having some low velocity. The low velocity means the organic solids, they can also be settled. Why? Because the specific gravity is low compared to inorganic solids, so that they take more time. So this is the reason why we are giving you the low velocity and slightly increased detention time so that organic solids can also settle down. So here we go the detention time up to 3 to 4 minutes, and we're going up to 0.09 meters per second in the velocity of flow. So you can see here, this is the shape of the tank, practical tank. So you can have a rectangular inlet and you can see the outlet, and you can see at the bottom we have some shape here at the bottom where particles will be settled down. So this is the line diagram. So this is a cross section, and this is your H here. This is your H, and this is the length of the tank. Other side you have a length of the tank. Now for 5 MLD, if we look at the assumptions, let us take T is equal to 3 minutes and the horizontal velocity as 0.1 meter per second. We close to 0.09 meters per second. And volume is equal to Q multiplied by T, which is equal to 5000 meter cube per day into T. This is per day converting into minutes divided by 24 by 60 and then 10.5 meter cube. And length of the tank is equal to VH multiplied by T. So VH we are assuming as 0.1 meters per second into 3 minutes is the time. It should be converted into seconds. So 180 seconds multiplied by 0.1. So is 18 meters. And cross-sectional area BH is equal to volume divided by length. So 10.5 meter cube divided by 18, which is equal to 0.6 meter square. If I assume B is equal to 0.5 meters, H is equal to 1.2 meters plus some freeboard. So this is how we are getting here. This is width of the tank is 0.5 meters and the depth of the tank is 1.2 meters. And the freeboard is there and the length of the tank in this direction. Length of the tank is in this direction. So this is all about different forms of removing grit from the wastewater. First one, we have grit channel. They were manual separation or through gravity separation. Second one, we have seen aerated grit channel, where we are using diffused air to separate the particles from the wastewater. And then third one, we have seen the detritus tank.